42, the hardest part about a lot of these is just knowing what chart to use for a lot of people who are just beginning to understand this stuff. And in 42, I kind of break it down for you, and I tell you what chart. And then in 43, example 43, I don't tell you as much, and I want you to determine. But 42 with number 1, I did this one almost identical to this one in class last week on Thursday. So that's why I went ahead and put this one on the board. And I kind of stated this. I said, would you rather have $1,000 a day and know that you can invest it at 10%, or if I promise to give you $1,200 in 3 years? And to do that, you have to decide, well, how much money could $1,000 turn into at 10%? And we did this. We worked it out, and using the charts, we found that 1331. So it was better to get the money up front, especially with that higher interest rate. Now you can try this using the charts again, and obviously we're in the future value of a lump sum. Remember, there's 4 main charts. I may put those back on the board just as a refresher. We had 4 main time value of money charts, and go ahead and look at number 2 while I put this on the board. So with number 2, if I have 5,000 today, and this is just compounding a regular annual rate, so there's nothing real special. Your N is a very easy 18, and I is the 7. Nothing special we have to do with these yet. So we'll go to our chart, future value of $1, chart 38, number 38. Hopefully you got 5,000 to turn into 16,900 in 18 years if you were looking to put money away for college. So if you could put away at 7%, your money is going to more than triple whatever you put in if you did it for 18 years. Then we can look at it from the opposite point of view and say, well, instead of me knowing that maybe I need $16,000, let's say I know that I need $20,000 because I want to have money for a house. And I know that I can earn 6% interest. How much do I need to have right now? And that's the key with the present value of $1 table. I want to know right now, how much do I need? So that tells me I need the present value table, because I don't know the now amount. I know the future, I don't need the future value table. I need a lump sum that I'm dealing with, and I need to know the amount that I need now, as chart number 39 shows. So I think that shouldn't take you more than about a minute. Interest, so it's just compounding annually. In 3, number of periods, 6% I. Make sure we got chart 39, present value of $1. If I put away $16,800, I'll be at $20,000 in 3 years. Mm-hmm. When you get to number 4, it's not exactly realistic, but our charts don't allow me to be that realistic because our charts only go up to 50 periods. Now, we could easily get charts that go way higher. But for that reason, I'm having to assume on number 4 that I only put money away every year, instead of more realistically on number 4, putting money away at the end of every paycheck, maybe every other week. Or putting it into the retirement account at least maybe once a month. If I did once a month for 17 years, that would be about 200 payments. And of course our charts only go to 50, so that's not going to work. So I just decided, let's go ahead and just pretend that I put it away every year instead of every month. And I put away 5% and my employer matches. And I want you to be able to tell me then, how much money would I have if I just decided to take the money that I had and the employer matched it and did nothing with it and didn't earn any interest compared to if I earned the interest? How much of a difference are we talking? We have to use the future value of the annuity chart. And then I also tell you in the beginning of number 4 that we put it away at the end of the year. That's key. By putting the money away at the end of the year, what's the annuity called in that case? I put money away at the end of the ordinary annuity, good. And if I put it away at the beginning, it's called
annuity due.
Annuity due, yes. This one I'm putting it away at the end, so I don't have to do anything special to the charts. They're set up for ordinary annuity. So how much gets put away every month, every year? How much do I put away?
3,000.
3,000, right. 5% of 30,000 is 1,500, and if my employer matches, I'm going to put away 3,000 every year into my retirement account, and that would be that could be realistic. And this would be, let's say, if you retire at age 65, this would be you starting your retirement plan at 48, which is a lot later than you should. And then I want us to compare, once you've done the 17, I want you to compare, what if you had even started 25 years instead of 17, where I want to compare those two. Let's say we pushed it back, instead of starting at age 48, we started 8 years earlier at age 40. How much of a difference is that gonna make? We probably have had time now to do this one, I hope. I put away $3,000 at over 17 years, compounding at 8% per year. I would have 101,000 to retire on, which is good. It just kind of depends on your lifestyle, how good that is. But it's much better than not putting money away and not earning anything, and just putting it into a zero interest checking account.
Why, and I wasn't here last week, but why is it 8%? Oh, while I have earning 8% interest, I didn't see that, I'm sorry.
And now I want you to compare this to changing this simple number here and starting a few years earlier. If you start just a few years earlier, 8 years to be exact, your number more than doubles from 101 to 219. You didn't double the number of years. We didn't go from 17 to 34. But yet our dollar amount more than doubled. And then even better, if you would start, instead of age 40, when you start maybe a real job, you start earning a lot of money, not a lot, but a decent salary at age 30, add another 10 years to that. At 8%, you go from a factor of 73 up to a factor of 172. So 10 times that. Not 10 times, double. Yeah. Just calculate that, let's see what, I haven't done it. Take 3,000 times, if it was 35 years, because you started at age 30, and that is 172.32, up to 516,000, again, more than double. Just by starting earlier. If you ever hear people talking about putting money away as early as you can, that's why. Okay, number 5, we're in the same category here, so we're probably going to be using the same charts. Because, again, I'm dealing with payments. That's what an annuity is. And I want to know how much will all of those payments be worth in 18 months. Put $100 away and earn 12% interest. I don't know what it's worth in the future. Key word being the future. The only little difference with this one is I don't want to use 12% interest. I I don't want to use 12% interest. I want to use 1% interest. Because remember what the N and I stand for. N stands for the number of compounds or payments. So we have 18 payments because they're put away at the end of every month, and there's 18 months. And I equals your interest rate divided by number of compounds or payments per year. So if my interest rate is 12 and I have a compound every month, that means 12 per year, my interest rate is going to be 1. 12 over 12. Thing that's then different with number 6 is I'm not putting the money away at the end of every month, I'm doing it at the beginning. My charts are not set up for beginning of the month payments. I have to make a little tweak to it. And you should have this on the bottom of your charts. If you don't, I would do it right now. Your charts are set up as ordinary annuity. But if it's an annuity due, as number 6 is, and it's the future value one, add 1 to your N number, I, no change, and then whatever your number on the chart is, subtract 1. Then your charts can be used for annuity due purposes. So your N value is now we're going to look up 19 at 1%. And when you do that on your chart, you get 20.811. All I need to do is subtract 1. And that is now my multiplier. So I added 1 to the end, make it 19. Still I is 1. And then I took 20.811 and took it down 1. You always should have more money put away if you put at the beginning instead of the end, because you're earning interest faster. Any questions over 4, 5, or 6? The future value of $1 and how you might change the charts if it's a beginning of the month payment. Okay, the last chart, an example of what would be on it, the present value of the annuity. I shouldn't have put in the title there, present value of annuity due, because it's just an annuity. I'm due $20,000. And that would include interest being added in there. So with interest, it's 20,000 total. However, I decide, well, instead of having to pay me right now, I'll let you pay me over 5 years, equal amounts. At the end, keyword, end of every year. How much could the debtor pay me right now with this new agreement? How much is 4,000 over the next 5 years? 4,000 plus 4,000 every year. How much is that worth right now? How much am I allowing him to pay me? How much could I accept? And neither of us would be any worse. And then we're going to prove it to make sure that nobody's getting ripped off. So I know what the future amounts are worth. I'm allowing him to pay me $4,000 a year to get to $20,000. But how much could he pay me right now instead of all those monthly payments, and neither of us would be any worse? So we look at our last chart, number 41. And when I give you two amounts, like I did here, you got to be able to pick which one is the right one to use. And you'll know the right one to use because what's going to happen, let's say I didn't even offer him this deal. I didn't give him the opportunity to pay me right now say I didn't even think about it. What is that guy going to normally do then? Is he going to pay me the $20,000 or is he going to pay me $4,000 a year? What's the more realistic option?
Pay you 4,000.
Yeah, this one. This is the number I'm going to use in the scenario. This one isn't really an option anymore. Once you give somebody the option to make payments, usually that's what's going to happen. So I'm now focused on payments, and I want to know what are all those payments, what are all those future $4,000 payments worth right now? Well, over 5 years, and it's 5, my interest rate per year, I only have one compound per year, so it's 6%, the given number. If this person paid me $16,848, that's the same as paying me $4,000 a year for the next 5 years. And we're going to prove it. And I have you prove it on your quizzes and exams as well, because I want you to be able to show somebody that if you do this ever, and you can do this in real life easily, and not only be able to provide them an amount like $16,848, but say, this is showing, then I'm going to prove it to you that we both come out the same. So up here, I'm going to show you gave me $4,000 payments. How much is that worth in 5 years? $4,000 yearly payments. Or if you give me $16,848 lump sum, how much is that worth in 5 years if I were to invest it? Both of these I'm going to invest $4,000 a year at the rate that's given, or $18,000 at the rate that's given. calculator. For this first one up here, what chart am I going to need to use if I want to figure out how much these payments are worth in 5 years?
Future value
That's not enough.
of annuity.
Of annuity, yes. Because future value could be of $1 or of an annuity. But you're right, future value of an annuity, which is number 40. And if I look up our 5 periods at 6%, that's 5.637. And then multiply that by my known amount, $4,000. If I put $4,000 away every year for 5 years, I would have $22,548 in the bank. If instead I took the $16,848, and then what chart am I going to use for the bottom part, the lump sum? I want to know what 16,000 is worth in 5 years. Trent?
Future value of $1.
Future value of $1, good. 5 periods at 6%. Yeah, I get 1.338. 22,543. And these are basically equal due to rounding. Remember, $1 per 1,000 is very acceptable. I'm only off 5 out of 22,000. So basically, it's the exact same amount, regardless of which method. And that's what I wanted to be able to prove. 16,848 is the exact same as receiving 4,000 a year for the next 5 years. What's the only difference then with number 8? When number 8 says that the payments are to be made at the beginning of the year instead of at the end. Now we've got to do a little bit of change to our charts. When it's annuity due and its present value, so on your present value chart at the bottom, I would put, if it's an annuity due, whatever your in is, subtract 1, just the opposite. Whatever your I is, no change. Whatever your number on the chart is, add 1. So on number 8, my N is now 4 at 6%. I get 3.465, but then I need to add 1 to that, 4.465. I could just as easily prove this one as well. then I tried to make that little box that I had, those little reminders, here at the bottom of your sheet. So you have something to refer back to remember what chart should I use in each situation. It's not very hard once you, it's only two little steps to look at for each one. All right, now we're going to see how well you are really getting this by looking at number 43. And about every 5 minutes, I'll scroll down and display the answer for each one of these as we go. Some of you will get done with these real fast. Some of you will take a lot longer. I'll try to be about in the middle. You should have relatively no problems with 1 through 6. Number 7 gets a little trickier, and number 8 we'll go through in a little more detail. One thing to keep in mind, give you a couple pointers before you start here. On number 1, simple interest. This is simple interest, what we've done up until this past week. PRT. That's simple interest, where basically you're just given a principal and then you figure up the interest based on that one lump sum amount. Like what we did with if I took out a loan for $6,000 and paid it back in a year, we had assumed in that case simple interest. I was just earning interest on $6,000. Well, that's not necessarily the case always, like with your credit card bill. If you don't make a payment, or your student loan bill. If you take out $10,000 in student loans and don't make a payment the first year, they're going to start calculating interest not only on $10,000, but on $10,000 plus the interest that you racked up that first year. So what's the difference between simple and compound? Compound, your charts are designed for compound. Charts are compound. That's simple. And then with number 3, when something is quarterly compounded, well, that means there's a kind of like a payment, although it's not, but it's treated like that. Your N isn't going to be just 5. Give you a hint. And your I will not be 8, because you're having a compound 4 times a year. All right, so we're going to work on this for probably about, I don't know, maybe every 3 or 4 minutes I may put one up. And then for the videos, I may have those turned on about every 10 minutes to give you a recap of what we've done, maybe after every one or every other one. I'll give you a few minutes to get started, then I'll start putting up some of the answers for these so you can check your work. Get in the habit, though, because I'm going to have you do this on any quizzes or tests or homework. Get in the habit of always telling me before each one, what's the N, what's the I, and what chart did I use? I want you to put that next to every one and then show me your work. 4,000 times 4.462. Okay. So the key word here was compounded quarterly. That means 4 times a year. And if I do something for 5 years at 4 times a year, 4 times 5 is 20. And then the interest we had on the board a little bit ago, your interest rate 8 divided by how many compounds are you having in a year? And it was 4. So 8 over 4. And now we got the 2.
Thank you.
Number 4, same situation as 3, except I wanted to look at it from the other viewpoint. Meaning instead of putting $300,000 today and what will I have with all of that money in the future, what can I put away right now to get to $300,000 in the future? If I'm compounding quarterly over 5 years, I could put away $201,900 and get there. I know the future amount in number 4. I don't know the present amount. So that's why I use the present value table. Well, for 5, you put away $10,000 at the end of every year. So that makes it an ordinary annuity, nothing to do with your charts, nothing special. Put away $10,000 at the end of every year for 6 years. Instead of having $60,000, I'll now have $81,150. I know I'm making payments, and I want to know what those payments are worth in 6 years in the future. So that helps tell me what chart to use, future value of those payments, future value of an annuity, number 40. And then number 6 is just updating your chart just a little bit so you have an annuity due. Six plus 1. And subtract 1 from the number on the table. So you originally get 10.089. I almost increased by $10,000 just by making my investment at the beginning of the month, beginning of the year. I earn almost another $10,000 in interest. I still put $60,000 away, but almost another $10,000 in interest because of such a high interest rate. When you get to 7, you're going to have to do number 7 twice. Because you got to figure which one's the better option. Is it better to take the big payout of $2.5 million, taking half of your money right now, or getting all of it spread out over 20 years at 6% interest? This one, we're going to tweak it just a little bit and see how it might be different. But let's do it at 6% first. The payments, by how much? About?
It's a little over $1 million, ain't it?
Yeah.
It's like 17,500 if you do a lump sum, and
That's right.
918.
Good.
Up there.
So with this interest rate, which is a little maybe low, I don't know, but it's 6%. In this case, it's better to get all of your money, and even though you're not earning a lot of interest on the smaller number, 250 instead of the 2.5 million, it's better to go ahead and get all of your money and still earn some interest instead of at the somewhat lower rate taking a cut of 50% if you were looking to get the maximum amount. Now, I don't want you to always think that getting the payments is the best option. What if this was increased to 12%? Do the calculation, assuming everything's the same except all of a sudden with that much money you can get a really good investor and earn 12% instead of 6%. And let's see if the payments or the lump sum is the better option at that point. And then why, if there is a change, why? Why is it better at the 12% rate to say take a lump sum or the payments? What's the better option long term?
Yeah, mine did, because, I'm not really sure why it did, but, it seemed like it was double for the lump sum, if you just,
So how much difference did you get between the lump sum and the payments with the 12%? About?
About, let's see, like 24 million.
A little high. Melissa?
I don't know, I'm still trying to wrap my head around this.
Rebecca?
For the 2.5 million,
Mm-hmm.
24,115,000.
Okay. Well, what's the difference between option 1 and 2? About?
About 6
I haven't got
million.
that part figured out yet.
Yeah, about 6 million. At 12%, there's about a $6 million difference where the lump sum is better than taking the payments. If I just take the payments, I'm not going to do as well. So it's not always is the lump sum the better way or the payments the better way. It all depends on this interest rate. At 6%, yeah, the why, what's your thinking then of why at 6% the payments is better and at 12% the lump sum's better? Anybody got a rationale? You think it's always like that? With this high, this would be considered a high interest rate. If you're going to take a high interest rate, you're going to want to multiply it by as high a number as possible. You can get a lot more interest on 12% at 2.5 million than you can at 250,000 at 12% interest. And when the interest rate's smaller, that difference, even though, yeah, you're going to get more at this amount, the amount that you're going to get isn't enough to make up for you taking a 50% cut up front. You're going to do better if you get all of your money, even though you get a smaller interest. Here, your interest rate's so high that even if you do take a 50% cut, you're going to more than make up for it with that nice high interest rate. That's the reasoning behind it.
Do you know, does the lottery normally do a compounding rate? Or is it just a simple rate?
No. You've got to do your own rate. The lottery doesn't rate for you. The lottery just says, what option do you want? I'm either going to give you the money or I'm going to give you the payments over time. and then it's what you do with it.
Oh, okay, I see what you're saying
Now, if you pick this option, the lottery is gonna do it from their point. They're gonna say, okay, I've gotta pay out 5 million over 20 years. I better start investing that money so I have that much to pay out. Otherwise, they say, this is how much we earned on selling tickets. We earned 2.5 million, and so I can go ahead and give you that amount and you want. If you pick to have the 5 million, they say, okay, I better take this 2.5 million and invest it, so then I can get 250,000 for the next 20 years. Last example. This is a real case. Really happened to me. I did this. I found a computer that, this was probably, it's been a little while now, 3 or 4, maybe even 5 years ago. I went into the Best Buy out of McGalliard. I saw a computer that, they had it for $720, but they were giving a deal saying, instead of paying $720 right now, you can just pay us over 18 months. So if you take $40 times 18 months, that comes up to be $720. And they were doing that same as cash. So meaning no interest if you pay it in 18 months. So I decided, well, if they're going to offer it to me and allow me to pay over 18 months, wouldn't Best Buy rather have the money right now, you think? If they had the option, would they rather get money right now or wait 18 months to get their whole money? Well, if I'm the business, I want the money now. Because what can I do with the money now that I wouldn't be able to do if I got it slowly?
You can invest it all.
I can invest it, and what would Best Buy invest it in? They probably wouldn't go buy stock. They would do what?
More inventory.
Buy more inventory, yeah, and resell it. And I assumed, and I think it's a pretty low assumption, I said, well, if Best Buy has a 12% what's called internal rate of return, internal rate of return, meaning they can take my money, and let's say I give them $1,000, within a year, they could earn 12% on that. Meaning they could buy inventory, sell it for their markup, and after a year, instead of having 1,000, they would have 1,120. Because that would be 12% by earning markup on their inventory. So if I was Best Buy, I think I would want to entertain some deal maybe. So I go up to Best Buy, and I know not to ask the regular the clerk at the register, because they wouldn't be able to do this. So I went to ask for the manager of that department. And I said, okay, since you're offering me 0 interest and I could pay it over 18 months, why don't I just pay you right now, same as cash? And I'll pay you the present value of $40 a month for 18 months. And I had to go, I didn't do this all in one day. I went and checked it out and went home, did the calculations, did the proof, and then I went in and talked to the manager. How much did I offer Best Buy to be able to pay for this computer? Calculate that out. Nobody gets out any money, and then I want you to prove it. Now again, I give you 2 amounts. Monthly one and a 721. What's going to be the realistic one that I would choose if given the option like there is here? Which one do you need to focus on? The payments or the lump sum?
Payments.
Yeah, the payments. This one's out. Nobody would pick that one. So I I want to know how much are all of these payments in the future worth now? What are all the payments worth right now? 18 payments. Interest, well, it's 12% interest over 12 payments per year, so that's 12 divided by 12. That computer is really worth $655.92 with the current deal that they are offering. It's not worth $720. And we can even prove it. I tell Best Buy, here's what if you're going to make me pay $40 payments every month for 18 months, this is how much at 12% interest, if you earn 12%, this is how much you'll have. Or if you pay if I pay $655.92, this is how much you'll have. So we get out our charts. I'm going to do the top one first. $40 payments. And then the annuity, N is 18, I is 1 of the future value of the annuity. They earned and invested it in inventory at 12% return. If on the other hand they had $655.92 lump sum and started buying inventory and selling it on future value of a lump sum 1.196, 784.48. So within 12 cents, they're identical. 48. What do you think? Best Buy take the deal? Did Best Buy say, you're right, $655, or did they say no? They should have.
They'd say, huh?
They did say, huh? Until I got to the highest level, and then they did not. Even though, and the reasoning he gave, which I can understand, is they have an agreement with HSBC Bank. If you buy something on credit, Best Buy gets money right now. HSBC Bank pays Best Buy a set amount, and then you pay HSBC Bank back. Now, Best Buy doesn't get $656 from HSBC Bank. HSBC does this. They say, all right, the value of us getting $40 a month is this. Now, if we just give Best Buy this, then we're not a very good company. We're not making any money. So they're going to take a fee out of this, maybe, I don't know, 20% fee, 10%, whatever it is. So whatever this, $130-ish. So Best Buy, when they sell me this computer for $720 total, they're really only getting cash of maybe $550. HSBC pays them $550. I would pay back HSBC Bank the full $720, and then they would earn their fee on whatever rate that they charge. So Best Buy would really have been better if they would have cut out the middleman and just taken my deal. HSBC now is the middleman, and they get the extra money. For extra credit, and this is where we'll end the day, we're not going to, one step back. Number 43.5, this isn't due until a week from today, but everything on 43.5, you know how to do now. So if you wanted to do it early, you could. 43.5, that's due a week from, so actually after break, because we won't be here next Tuesday. What?
Said if it's the Thursday, it'd be.
No, it's Tuesday. It's Tuesday.
We're not here on Tuesday either.
Right.
Right.
So it won't be next Tuesday because we're not here. But if you wanted to get a head start on it and not have it due and not have to work on it over Thanksgiving, you could do this now. Number 43 and a half, 2 pages. We're not going to get to cover 44 and 45. But if any of you had looked ahead on 45, I had an extra credit opportunity. I'm not going to use this extra credit opportunity, but I will exchange it for something else. I'll exchange it for something very similar to this, and I'll write up some details. But over Thanksgiving, lots of ads will come out, obviously. And some of those ads will say, 18 months, same as cash. And they'll give you a payment rate. What I want you to be able to do is something like this. This will be the only unknown factor that I will want you to use. I want you to assume a 12% internal rate of return. You're not going to know what that is unless you go into their financial department and get it. But we'll assume a nice, convenient 12%. It's not too high, not too low. And what I want you to do is if they're selling a refrigerator, or maybe H.H. Gregg, and they say you can pay us $100 a month for the next 24 months, how much could you pay them right now instead of $100 a month for the next 24 months? You can't, you don't have to, but if you want to, you can send it to me, I'll review it. But then what I want you to do is do what I did. I want you to go to H.H. Gregg and say, H.H. Gregg, I've done this work. Here's my proof. I'd like to buy your fridge instead of $2,400 over 100 months for $2,150. And see what they say. If they say yes, then you can say, well, I need to talk with my spouse. Or my significant other.
I'd be ready to buy a new washer and dryer.
Walk
see if
out.
it works.
So you can do this and earn extra credit while you're doing it. Save money. So, and then you write up a half-page report on what happened if they allowed you the deal. If you go and try this at Walmart, it's not going to work because they're too big. But if you go to a smaller store, it very well will work. And see what happens. Okay? So that'll be due after break as well.